we don't want that to result in any risk of poor air quality issues. So we have to have something that's more compatible with the new Part L. Yeah, it's going to result in zero carbon ready homes, isn't it? We all know the definition. It means that they don't need any retrofit to achieve zero carbon. They're just waiting on the grid, on the power supply to clean up to achieve that status. We will see an end to fossil fuel home heating. Gas and oil just can't hit the marks that have been set for primary energy and carbon emissions. So it's all heading towards electrical power, and of course, not direct electrical, it will be heat pumps. Yeah, just mentioned the bottom there. Preparing for this topic, I see there's been some criticism in the industry arising from the consultation that there's been little consideration given for embodied carbon in building components and materials. And whilst I have some sympathy with that, and I think that's quite a sensible observation, I just wonder, as a simple building control man, how complex it would be to try and bring in those sort of criteria into building regulations. Yeah, wiser minds than mine might get their head around that, but I can't. So I'm quite relieved that it's a little bit more simple. So the main crux of the Future Home Standard will be the home energy model, the HEM, as we're going to call it, and that's replacing SAP 10.2, the standard assessment procedure that we've been using up to now as the approved methodology to demonstrate Part L compliance for new dwellings. And as with SAP, the HEM sets targets for the 3 metrics, so it's not changed those. Most of you know they are obviously carbon emission rates, primary energy consumption, and fabric efficiency. So the HEM, just to give you a few points about it, it will probably be refined to use local weather temperatures rather than a national average temperatures. It will use separately calculated thermal bridging values, Y values as we call them, rather than accept defaults as the current SAP does. And this software will run a far more detailed simulation. So whereas SAP deals in monthly time steps in considering energy use, the HEM will go to half hourly. So in other words, every half hour of a year is evaluated in coming up with the output. And as part of that, the government will be hosting a centralized cloud-based version of the calculation engine that software providers can build their own interfaces around. And what they're calling this is I think it's the ECAS, another acronym, ECAAS, the Energy Calculation as a Service. So look out for that, and I'm sure the software providers will be linking in with that as soon as they've got all the details. There will be advantages to HEM in that it will be more flexible to evolve and adapt to new technologies as they come on stream. And let's face it, it is a fast-moving technology, so that can only be a positive thing. And as with SAP, the as-built version of the HEM will, of course, form part of the BREL report that Building Control asked for on completion to demonstrate compliance. BREL have dealt with it in the past. That's Building Regulations England Part L, and it's just demonstrating that a developer builder has built to the specification with photographs of all the key stages, etc., plus this as-built HEM calculation. There are 2 options being considered as the notional home in those home energy model calculations. I covered this before. I'm going to cover it in a bit more detail now. Just to remind you, what's the notional home? Well, that's the design specification that's put forward as achieving a sort of benchmark performance for energy that has to be achieved by all new dwellings. So it sets the marks in terms of emissions, etc. So you can see the 2 options there, option 1 and 2. Option 1 is the most cost and carbon efficient to run, but it does cost more to build. So there's more upfront cost to it, whereas option 2 costs less to build, but the running costs are going to be slightly higher than option 1. That said, there will be less than homes meeting the current standards. By the way, I haven't shown them, but there are also 2 notional home model options on the table for homes linked to heating networks. Not seen many of those yet, but maybe we'll be seeing more of those because of the efficiency benefits that they bring. Looking down the table there, you'll see that the fabric U values in the notional homes, both options are unchanged from the current. As we know, with U values and insulation thicknesses, it's a law of diminishing returns, and we've probably pushed that as far as we can in terms of cost benefit. And finally, on that page, yeah, only one of the options, option 1, includes wastewater heat recovery, which is quite an effective way of squeezing every last bit of heat out of the water that goes down your drains from the shower. Continuing on, so both options you see use heat pumps. As I said earlier, fossil fuel boilers in new homes are going to be history. Looking at air tightness, we see that option 1 reduces that to 4 cubic meters. And in doing that also tightens up on ventilation, so looks at a decentralized mechanical ventilation system, in other words a whole house system, continuous running localized fans running in wet rooms and kitchens, whereas option 2 can use the previously more common system of natural ventilation with intermittent extract fans in wet rooms. That natural ventilation isn't really compatible with lower standards for air tightness. I've said this before, I'm surprised we don't bolt on more onto mechanical ventilation, heat recovery and MEV and sort of scrap ideas of natural ventilation, because it all depends on how well somebody operates the system. And the more automated it is, the better air quality you're going to get. And let's face it, how many of us know what the quality of the air is that we breathe in our homes? It's not something you can very easily monitor. So in terms of photovoltaics, quite a lot to say about that. The notional specification, some of you might know, currently looks for a kilowatt output equal to 40% of the ground floor area divided by 6.5. And I'm told that equates to around 4 kilowatts for the sort of average sized dwelling. Now, option 1 of the new HEM considers 40% of the floor area as the minimum panel area. So we're mixing our metrics there a bit, which is strange. And I'm not quite sure how that compares. There's a lot of debate going on this topic. And that relates to the consideration of the cost benefit equation. Yes, PV will result in lower energy bills for householders, there is no doubt, but then it does mean that they're going to pay more for their homes because build costs are higher. And in terms of carbon emissions, I don't think from reading it's entirely clear on how big a contribution domestic generation can offer in the big picture of the national cleaning up of the grid, when you consider alongside grid generation in the normal way. So there's a separate ongoing consultation on the go on this topic, separate to the new Part L, and the consideration is to amend Part L to make PV panels mandatory on all new dwellings. So never mind the HEM and the notional home, actually make it mandatory. So there is the new draft requirement. As I say, this is just on the table, it's not been adopted yet, and it's suggested that either there's a fixed minimum output in kilowatt hours, or alternatively an equivalent peak power output in kilowatt hours, at least 40% of ground floor area divided by 4.5, as you see there on the slide. Now, I'm not quite sure how that compares to option one of the notional home spec. I'm surprised it's not the same. Somebody out there, if they've got any energy consultants, they might understand why they are mixing these metrics and just confusing simple folk like me. But that's the best I can give you at the moment. Just rounding off, a few other changes anticipated. Changes of use, things like conversions to form dwellings. We can expect higher energy efficiency standards for these, and a possible new requirement for building control to be given SAP calculations and Braille reports, so that we can consider the whole building performance of the converted building. Also, we're expecting much more detailed guidance on the commissioning of heating and ventilation systems, and also of home battery systems. Then again, as I've said before, you can lead a horse to water, etc., etc. But and the other thing is, well, who's going to be looking over the installer's shoulders? These installers are, in theory, experts and specialists. So if building control are going to look over their shoulders and check they're doing what they should in terms of commissioning, then I think we need to get involved in some specialised training, and the sooner the better. Promotion of smart meters, final point there. Not necessarily mandatory, I don't think. I'm not sure why. I think there are complications in some parts of the country of achieving that. But they bring obviously huge benefits in that householders can easily exploit off-peak lower tariffs for electricity. Maybe they can easily bolt on some extra storage capacity and link that to the system. And of course, a smart meter can have built-in provision for exporting surplus energy. So there's also advantages in that they can, in theory, be used for ongoing performance testing of a building, and that was mooted in the consultation as a possibility. But I think it's more likely that performance testing will be a bolt-on option, almost to help house builders to market homes, using testing to sort of prove real-life performance and give them a badge for that particular home. It does what it says on the tin badge, maybe something like that. But time will tell, and we can firm up on that when we get the final draft. Anyway, closing off, whatever happens, let's hope we don't get to the point with all the PV generation, etc., where householders have to pay the grid to dump surplus PV generation during very sunny periods. Some of you will think, what's he talking about? Well, in some parts of the world, believe it or not, USA and Australia, they don't want the system overloaded in sunny times with home generation, so the householders actually get charged to dump it into the grid. Not just USA and Australia. In fact, I saw this article today, even in Holland. So if it can happen in Holland, you wonder, could it one day happen in UK? Let's see that coming and avoid it if we can, or that will really take the edge off the demand for solar panels, won't it? Anyway, that's me. So I will stop sharing and hand over to Simon to take the floor.
Okay, thank you very much. Very interesting. I think I would probably say the way to avoid paying to have your electricity dumped onto the grid would be to install some batteries, but we'll perhaps come to that. Thank you very much, Trevor. I'm Simon Green from Green Building Design. We're a multi-disciplined M&E consultancy, specialising in all aspects of M&E design, but particularly at the moment we're doing a lot of low carbon, low efficiencies, and helping people out with low carbon designs. I myself is an engineer now over 30 years old, as a practice we are trying to be very, very sustainable, very, very innovative, and offering practical building services solutions to our clients. Sometimes low energy comes with compromises. Today I'm sat in my office, which is not air conditioned, so I've got the window open. I can hear some voices outside, so hopefully it doesn't come across. But again, that's some of the compromises with natural ventilation. I'm going to really talk today about. So I've lost my button on. I'll move into the next slide. Won't I move?
It's down the bottom.
Got it. Yeah, sorry. Thank you. Yeah, thank you. For some reason it just did. Right. Sorry about that. Right. So what are we going to talk about today? I guess first thing item we're going to talk about is U values and enhancing them above the standards. The positive and the negative sides of that. You know, should we just be compliant or trying to go a little bit further, be better than the rest? I'm seeing a big uptake in direct electrical heating. Is this new making ground in our new buildings? Is it right? Is it wrong? Pros and cons. Then we're going to get a bit more smart, talk about some smart controls, AI self-learning, sensors, meters and displays. Do we need to start thinking about our mindset? Do we need to consider our mindsets changing? And then following just with a few questions when we get to the end. So to really get going, Part L of the building regulations say it's been updated, as Trevor's just explained, to align now with future home standards. Now, personally, I think that's kind of great news. It's going to lead us towards our goal of carbon neutral homes. At the moment, a lot of that plan will be, unfortunately, we use energy in winter and we export energy in the summer. So we need to get a balance of that. The simple option probably would be to have everybody have their own internal battery storage. Usually it ends up being next to your fuse boards, and in a lot of houses your fuse board is under your stairs. And to me, to put a flammable, potentially explosive battery under your stairs, I think is a little bit of a worry. I have had discussions with various battery manufacturers that assure me their battery has never caught fire. I've only seen Teslas on fire on the road and Chinese cheap batteries of car chargers going off. But when a battery does get overly hot and goes into thermal runaway, it's a huge fire problem. So I think, you know, as we're obsessed with fire standards at the moment, batteries under staircases need to be absolutely banned, in my view, and batteries only need to be in a remote part of the house away from the escapes. But I do see that is the way to rationale things. Is batteries will creep into all our houses. Part L is going to be now the regulatory baseline. You know, we need to review this, I think, as the minimum, not the thing to achieve. And we also need to, consider now integrating smart controls, principles, changes in lifestyle, to further leverage those advances, technicians, and look of ways of using less energy. Design principles, need to surpass, I think, these regulatory requirements, and let's benchmark our designs by being fuller and over the top. Sorry, I'm having a bit of an IT. I can't seem to change my slides. So as Trevor's alluded to, there are the standards of U values that we need to a minimum adhere to. Now Visria is kind of preaching a fabric first approach, and it's really crucial for designers new and old to really start looking at fabric first over any design, both in new buildings and I think more importantly in existing refurbishments. To me, it's far too easy for the architect, for somebody else to say, oh, it's too difficult to insulate the walls, it's too difficult to change the windows. And ultimately, if you don't, we're still going to be left then with a high energy use building, no matter what source you use to heat it up. If we can look at the walls, if we can look at the windows, the ceilings, and the floors, and insulate that building to a similar standard as a new building, we are going to massively reduce the amount of energy we need, and really have an impact on carbon. So I'm very, very pro now with Visria on the fabric first approach. Clearly, once you've paid to have the refurbishment done of the window walls insulated, then you'll remember for the rest of your time, the energy bills. I think we just need to have a bit of a word of warning with heavily insulated buildings, even in today's moderate-ish climates, and the risk of summertime overheating. And we need to really ensure that with good sophisticated modelling, that the windows do open far enough on two facades to allow for pre-cooling, natural ventilation, and stop, which is becoming quite a problem on a lot of new housing, is overheating in the summer, where tiny windows that don't open fully aren't able to self-cool. And then, of course, if we can air condition those new houses in the summer, then we're going to impact on the energy of use of them. But by enhancing, the building envelope with improved insulation and air tightness, we are going to significantly increase the comfort levels. Stop all those drafty old days. When you're old like me, you can remember being in cold, drafty houses. And I'm even now starting to see people considering, with direct electric, and they can't afford a heat pump, or there's problems with the heat pump, going back to the older style night storage heating. Where night storage heating basically was a direct heating source. It charged up a local source of hot bricks using cheap tariff energy costs in the night, and then that heat then dissipated through the house in the day. Now, it was considered problematic in terms of once the heat was run out, you're then on expensive electric, or days when it heated up and then the house got overly hot because you didn't, the controls were quite simple. But certainly people are reconsidering, is that an option for their house if a heat pump is unaffordable or not practical? We also have some of our clients now that actually have a heat pump in an area where they had night storage heaters, and they're looking at trying to run everything at night on the cheaper tariff, even though the efficiencies aren't high, and have the hot water charged in the middle of the night, have their car charged in the middle of the night, and the heat's heated up as high as they can. Then with an over insulation, you have a high thermal inertia, which holds the house hot for most of the day, and then allowing the heat pump to only come on maybe late afternoon. So the tariff and the way the tariffs are used are becoming much more of an important point now, and something that I would say a lot of engineers have probably forgotten about night storage heating and cheaper tariffs of night to offer some solutions. We do, I think, need to consider then is, what temperature should we be heating our house to? My teenage children, love walking around in the winter in shorts and t-shirt, no socks on, turning the thermostat up and complaining they're cold. And when I ask them to put their slippers on and some, and a jumper, you're looked at like something ridiculous. And I think as a lifestyle change, it is worth considering that, if you drop your thermostat by 1 degree for every day of the year, on average, that's going to save 20% of your energy cost. Now, if you get down to 16, that would overall give you around about 60% saving on your current energy bill. Now, I am not suggesting on this call that we would have 16-degree heated house, because that would be too cold. But if you're lucky enough to have a very large house with some of the bedrooms that aren't used regularly, please turn the thermostat down to 1, shut the door, keep those rooms at 16, and you will see some impacts on your energy bill, and ultimately carbon reductions, which is what we're trying to do. PV, obviously Trevor's already touched on that already, has to be fitted on all new houses. My view, you need to put on as much as you possibly can. Certainly if we're going to put a heat pump in, we, in my opinion, absolutely need to have PV on heat pumps at new and old houses. And with some smart controls, we really need to ensure that your plumber that's never done this before in his life, calls himself a heat pump expert, he's doing your house for the first time, changes his mindset and make sure that the PV provides all of the energy to heat the hot water to your house for your washing and for your showers. And again, that load should be sized so that we're trying to utilize all of that energy to heat the hot water. And even in the winter, we'll still get 25% of the peak, so we should, even in the winter, be getting a good chunk of our hot water for free. And my view is use all the energy you're generating, because selling to the grid's not very efficient, which then does lead you down the line of probably considering batteries, and some good analysis on how much your peak load is, how much you're going to use, and then trying to use that energy from the battery at times when the solar's not very well. So the regulations are starting to lead us towards net zero, and I think the journey that government are on, they are going to continue us down leading it. And I think my view on the regulations is, why wait? Let's get on with it now. We've got the technology, we've got the computers, we've got the willpower. Having that extra amount of design, an extra amount of insulation and controls. When you're building a whole new structure, does it really cost that much more? Maybe it does cost some more. Is it more attractive now? We unfortunately get involved in some poor quality refurbs where, the client, the architect, I'm not quite sure who, they've already decided they're not doing fabric upgrades. We're going to put panel heaters in because they're cheap. And then we've had to try and explain that, to be marketing on today's standard with an EPC brand new flat at E or D is not really, in my view, acceptable. We need to really try and discourage developers and architects and decision makers that very, really cheap, horrible, yucky type retrofit office construction is not appropriate in our today's market. It's not fair to have a house, a little bedroom flat, and you've sold it on EPC E or D, knowing full well in 5 years they won't be able to sell that flat, and they're going to pay £3,000 or £4,000 a year to heat that flat. I think it's really important that as engineers we give that advice now to these clients. Say, look, you've got to be aiming for the best. I'm afraid you've got to be looking at a heat pump or a combined heating and cooling system for this whole building on a central vac system, to make it fair to the people you're selling it to. If we're not careful, I could almost see, rubbish fabric upgrades and panel heatings being the next, problem of flammable cladding. Because in 5 years' time, you'll have thousands of people in these 1970s, 1980s rubbish offices that have been converted to cheap flats, and they're unable to sell them. And there isn't really a sensible solution to put heat pumps in, sensible solution to re-insulate all the walls. Or there is, but it's very, very expensive for the tenants. So I think, I'm really seeing that we've got to educate our compadres of that. Implementing strategies now to align with net zero and carbon goals. We should be ahead of our regulations, and people that are trying to just barely do the minimum and not actually do the minimum. We've got to discourage that and encourage efficiencies. The benefits speak for themselves. Clearly, if we can do this extra insulation and have a high efficiency heat pump, they will have reduced overall energy use. Lower energy consumption will lead obviously to electrical cost savings. Enhanced indoor comfort. If it's not an old drafty 1970 office facade, it's going to perform pretty well from a sound and certainly from a thermal comfort point of view. Clearly, if we design today to improve the regulations to beyond and the standards of where 2030 commercially or 2035, I think domestically we're going to end up, we're future proofing our building to make it regulation proof. Then there isn't going to be need for retrospect or compromises down the line. In highly insulated homes, with fabric improvements, the heating demand is going to be minimal. And I think that the manufacturers of direct electrical heating are latching onto and saying, well, you know what, we don't need a heat pump. We can put panel heaters in because they're cheap to install and it doesn't really cost much to run. Because there isn't a great deal of heat loss in your new dwelling, and I guess they have got a bit of a point. If you think we're exceeding building regulations, and you could have quite easily a reasonable sized dwelling, but the heating bill may only be £300 a year with panel heaters. Now, is that acceptable? Maybe it is acceptable. The Dimplex run, a load of great big branded, water-based central heating systems, super high efficiency, and and they're promoting that in new build housing, and it does say in the small print for new build housing only, and the electrical generation is a one-to-one instantaneous high efficiency 100% heater. Yes, that is true, compared to a gas boiler at maybe 97%. So it is 3% more efficient than a boiler. but it still needs the water in the radiators to pump it all round. And gas costs at the moment commercially are 20%, 25%, depending exactly what tariff you're on. So suddenly your £300 could be dropping down to £60 if it was gas to heat that house. Now £60 to heat your house with gas sounds a lot better than 300, doesn't it? But this is the way the market's going. We're not allowed to put gas in new houses, so electrical options. So I think it's important just to see where the market is going and ask yourselves, is this correct? Is it not correct? A long time ago when ground source heat pump was first being marketed, it was described as much, much more efficient than air source heat pumps. And they kept quoting times where the ground temperature, say, typically is 10 or 12 degrees all year round. And, there's plenty of times of the year when the heating or the air side is lower than that. Therefore, at that particular time, the heating load on the air source heat pump would be working harder and therefore less efficient. And that's all they kept saying is, ground source is more efficient. But when you drill into the detail, it always excludes hot water. Now, again, even on newish houses a few years ago, the load on the building is going to be more for the hot water than it is for the heating. And certainly on modern houses now, it's much, much lower. So how many times of the year is the outside temperature above 12 degrees? Probably more than it is below. And all of those times it's above, your hot water is more efficient. So again, with all of these manufacturers' claims of super efficiency and highs, the devil is so much in the heating. So, direct electrical heating, panel heaters, is making a return to our buildings because the heating demand is very, very low. And we'll just gloss over the hot water heating for showers and baths and water use. Now, it's a real problem for that because if you go instantaneous, yes, their efficiencies are great. You only heat the water you need. There isn't any standing losses of a tank, and therefore it is more efficient. But as I've just said, the cost of electricity, can be 4 or 5 times domestically higher than gas. So be careful that your £300 a year heating bill doesn't suddenly turn into £1,000 a year because you're paying £700 for your hot water. So one of the options for that then is a tank. We need a tank of hot water then with immersions. Again, 1-to-1, so the efficiency is 100. If you could go with that system, to me, it's absolutely essential you have a 48-hour tank that stays hot for as long as it's possible, and all of your PV is used, even in the winter, to try and drive that temperature up so that at least all of your hot water is being heated by the solar and help cut down on those costs. We have a problem in our country that our electrical energy is too expensive, in my view, compared to gas. And sooner Ofgem do start changing that, that will therefore make us, I think, have these problems mitigated and gas dropping out. But please remember, the reason why we've been promoting heat pumps all these years is because they are 3 to 4 times more efficient than direct panel heaters. Yes, there is some issues on temperature. Yes, there are issues on space, controls, and who's going to fit them, and obviously installation costs. But they cost 25 to 30% the cost of panel heaters. And again, if you run that number, let's say it is £700 a year saving. It doesn't take that long to get up to 15,000, and then it's starting to not be as an efficient solution. So controls, the main point of the lecture is smart controls. Is how are we going to pivot smart controls to achieve more energy savings? It goes back a bit where Trevor was talking about them trying to revolve the SAP to look at half-hourly data and start looking at all of the mid-seasonal type conditions of when we should or shouldn't have the heating on. And as engineers, and I'm no different. We are taught. We design our heating system, for when it's -5 outside and it's wintry. We are taught to size our hot water tank. There's 5 bathrooms. Well, everyone's going to have a shower and there'll be 2 in each. Therefore, it's 10 showers a day, plus. And you end up with, a correctly designed system that will cater for when it's worst condition, i.e. very cold, or in the house in high use. But there is lots of times in the year where the design criteria outside -5, the house full of 10 people, is not there. So controls need to be self-learning. We need to be trying to adjust those controls. And probably the most obvious one, which actually has been around for quite a long time, is a self-learning weather compensator on your heating system, and that will track over time the outside temperature, the set point of your inside temperatures, and kind of monitor how quickly you got up to temperature. And then because the controls may take a little time to switch off, it will monitor the amount of over temperature you go, where you go over 21 for a period of time, and you make it, it's a bit warm in here today, and you manually turn your radiator down, your TRV. On those mid-season days, the day suddenly it's 9 degrees or it's 15 degrees outside, and gosh, it's hot in this room. So those sorts of controls are really trying to preempt, oh, hang on a minute, the outside temperature is this. Last time we were like that, we overheated by that. Okay, I'm going to switch the temperature off when the radiator says it's 19 degrees, because I know there'll be some residue heat in the radiator that will just bring it up to 21, and there'll be a bit of solar cane come in. So there's lots of smart learning technology trying to stop overheating, stop that extra waste, and really try to minimize the amount of energy going into our buildings and compensate that with solar gain or the internal gains, to know that it regularly knows that with the meeting booked, this meeting's been booked for 4 people in this room or 10 people in this room, that it knows it's going to get an internal gain fairly soon, and then try to switch the heating off before it overheats. And another way, certainly maybe more with offices, where dominantly we've designed this meeting room that's got 12 people in, for 10 litres of fresh air per second, because that's what it says in the building regulations. And we need to ensure that it works when it is full of people. But that meeting room, for big chunks of the time, won't have all those people in there. So with CO2 sensors monitoring at the extract air, we can pick up that if there's very, very low levels of CO2, then our controller knows very clearly that there isn't many people in that room, and it can modulate down the fresh air going in. Now, it may sound very high tech and very, very it's a lot of effort for one room, but if you magnify that across a building, and if you had a big 10-story building, and you could monitor that back floor by floor, and say, well, actually, hang on, the designer set the fresh air to come on at 6 o'clock in the morning. Well, I think we probably know most offices aren't full at 6 o'clock in the morning. If that's what the control says, you'll be bringing full fresh air in at 6 a.m. There's a lot of energy there, heating that air up, cooling it down, a lot of energy pushing it around the building to all those different areas. So if the CO2 can look at it all and say, well, 6 a.m, yeah, it's supposed to come on, but my CO2 levels are such a level, actually, I need to not provide any fresh air. And then at 10 past 7, it starts picking up. There's a bit of CO2 detected. Okay, well, we'll bring it on 5%. And that type of thing, lunchtime, it could potentially shut it off most lunchtime because most people have gone out for lunch. And that type of control, that makes tremendous savings. And, the EPC default models, which is a pessimistic view, would say 18 to 20% of the energy can be saved with CO2 controls. So, AI and controls and really, really thinking and reacting to buildings is going to be, massive amounts of savings. And all of those things can be retrofitted into existing buildings relatively cheaply. So if there's any landlords on the call, you really should be thinking about these sorts of controls, because 1, it will improve the EPC, and 2, it will save you and your tenants, real serious amounts of energy. Obviously there are simple things with absence detectors to turn lights off, lights, with daylight dimming that will dim them down, and really look at that way of reducing energy with good smart controls. Mechanical ventilation. I'm a bit torn here on this lecture now, because building regulations is talking you to get your buildings as airtight as possible. Get that, understand that, reduces my heat loss. Fine, no problem. And now, because you've got a completely airtight building, we need to put in a ventilation system. And building regulations are really, really good at giving you the minimum amount of fresh air needed to keep the room habitable. And it's all based on area. So you can have a bedroom, there's 1 or 2 people sleeping in there, that gets the same amount of fresh air as if one was sleeping in there. You go downstairs, the dining room. If it's the same size area of that bedroom upstairs, it will get the same amount of fresh air. But if you've got a Christmas dinner and there's 14 of you sat around the table, you're going to find it gets very, very stuffy and gets very uncomfortable. And in that sort of scenario, building regulations is not actually giving you the right information. So what happens then? Oh my God, it's all stuffy and hot in here. What do? You throw all the windows open on Christmas Day, letting in loads and loads of super cold energy. So I do feel with ventilation, building regulations and the minimum requirement needs to be checked with how many people are going to use these spaces. And do we need something much more complicated in our houses than a simple system that puts constant volume in? And I think the answer is yes, it does. If you want to be really comfortable in your new house, we need to have building regulations for ventilation with a real big pinch of salt on this side. If it's a really, really tiny flat designed for 1, maximum 2 people, okay, I'll go with that. You've got 1 or 2 people in the bedroom, 1 or 2 people in the bathroom, 1 or 2 people in the lounge, 1 or 2 people in the dining room. So I get that. But if you've got a larger house, I really think we need then a complicated system in there that then measures the CO2 back from each of those rooms. So 99% of the time, yes, it is giving you the minimum building regulations for that room, and it's just keeping it fresh. But then when that room's in use, it brings extra air either in from outside or it diverts it from the rest of the system. Because if you're all in the dining room, you're not in the bedrooms, and all the fresh air then can be generated to that one room. Therefore massively improving comfort, massively improving the air quality and energy conservation, because you're not then going to keep throwing open the windows or throw open the doors and then having that enormous amount of uncontrolled air coming in, which cools the space down. Somebody then moans, oh my God, it's freezing, and then you close the door, heating system's then working overtime to heat it back up, gets it stuffy again, and round and round you go. So PII sensors can shut down, I think, from your design air to minimum air, and certainly CO2 sensors can move the air around in a controlled environment. The ventilation, in my view, it needs to be adapted to suit the occupants, and sensors are a way to certainly achieve that. So even the smartest and most efficient buildings will underperform if the users don't interact with it, use it correctly. If we don't understand how our design is worked, and I think I'm alluding to that we really do need to have more controls in, and certainly apps on your phone now are a massive shift, I think, towards taking that hugely complicated Crestron system that you used to have in the meeting room that quite frankly nobody could really understand or control with, and then you would just press number 1 to have all the lights on and not all of the other settings. I think with apps now can make a huge difference to helping people be educated to adjust their decisions on how they use their design, and empowering them at their fingertips. And these apps have been around for a long time now. Having your heating set to 16 when you're on holiday, and you press 21 when you're coming through the departure lounge, so the house is nice and warm. And I hope now that future home standards encourages a shift in behaviour to start looking at using more materials and systems and educating people to adjust their certain lifestyles and habits. So hopefully then we can go on to the sort of key summaries to wrap up. Combining advanced fabric strategies with intelligent controls, I think, can position us to meet and exceed home future standards. Smart design isn't just about tech and technology. It's about making low carbon living second nature for its occupants. Considering using lower set points, switching items off, when generally not in use. Just try and use a bit less. Only have showers, not baths is an old one. design decisions made today are going to shape our energy use for decades. If you don't insulate that 1970s old council house, council block of flats, and use those panel heaters, it's costing you a fortune for ages. We have the tools, we have the software, we certainly have the willing. Let's use our design smarter and let's act sooner rather than later. And with that, I'm going to flick over to questions.
Well, thanks very much, Simon. Really good. And I think one of the key things for me was spelling out the benefits, not just to commercial buildings, but to residential buildings that can be bought by smart controls, CO2 sensors, weather compensators. I agree with you. Things like that should be mandatory. We've got to that stage where they can make such a difference to heating costs and air quality that we should be insisting on them. But maybe that's still to come. So thanks for that. You mentioned overheating, and I just thought I'd chip in there that of course Part O for new homes was brought in to try and mitigate against overheating created by new standards and a changing climate. And I think I'm right in saying that's being reviewed at the moment just to sort of assess its effectiveness. And who knows, we might see that tweaked again to be more compatible with the new future home standard buildings.
I just think, the software now is so easily there that somebody should really be doing the software to agree on design the heating system. So it's only a few clicks of the button then to check for overheating and guide the architect at day one that that type of window that only opens a small amount is probably likely to overheat, and stop it becoming a problem before it's a problem. And if that means there's got to be a different type of window design for planning, well, then that's the time to get it in, isn't it?
Yeah. Fine. Well, we've got a huge amount of questions.
Just got
did
one.
You want to run with those, Rach?
Yeah, this might be directed at you, Trevor. What is your view of U-value standards by LETI, which is the Low Energy Transformation Initiative?
Yeah, I think that was a sort of a London-based thing that was set up to sort of try and lead on low energy buildings and a sort of voluntary makeup. I'll be honest, and it's a personal view, I think we have one national standard and we stick with it. We had over the years, we've had planning authorities. Apologies to any planners out there. I love you all, I promise, but stick to your stuff and we'll stick to ours. Build into building regulations standards for thermal conservation, energy efficiency, and let developers and builders and architects have one standard to adhere to. Don't start muddying the waters and complicating things with other standards. So in answer to Sarika, I don't actually know what the U-value standards are in the LETI guidance. Maybe it's erring towards sort of passive house standards. If that is the case, as I said earlier, I think U-values and fabric efficiency is a diminishing return. And, we've got walls now that are, even with full fill high performance insulation, you're still looking at 300 mil cavity masonry walls. Do we really want to take any more floor area out just for a small gain in terms of energy conservation? So as you can glean, and I'm sure there'll be people in the audience who will disagree with me, but from my building control standpoint is no, stick to the regs. Let's have a set standard and no more. I don't know if you wanted to add anything to that, Simon. Have you got any thoughts?
I think ultimately it's levels in the detail, and we often will model for architects different wall constructions, not normally with an increase on the thermal insulation, and and there is a point of economic, as you say, and no returns that we are getting pretty close there, and I think it depends where you're starting. If you're starting on a brand new house, then I think we're kind of getting there with building regulations. If we're starting on refurbing, then I think we need to do the models to look at the increased extra insulation against the loss of net area. And you say, most of the time we end up with 100 mil structure internally on existing, which is a bit of an air gap, 75 mil insulation, and then a plasterboard finish. So 100 mils seems to be about the economic model on our experience, but unfortunately each building does slightly vary. But yeah, as you say, to sort of put 200 mil on those rooms would have quite an impact, and financially not that great gain on the heat loss.
And of course, the elephant in the room is we're talking about new buildings. Yeah, there'll be an ongoing benefit building after those buildings are built, but the huge issue really is the existing housing stock and how we bring up to spec and make that energy efficient. And that's a whole 3-hour webinar in itself, Rachel. I'll let you sort that out. I'll make sure I'm on holiday when we do that one. So for another day.
There are a couple more questions come in on the subject. So one from Matt Sutton at Space. How likely is option 1 on the notionals section how likely is it to be going ahead? So slightly scary, the thought of telling clients they will need a ASHP and PV.
Well, I think it's highly likely, is my honest answer. I think I'd be surprised if they don't go with option 1, especially with bringing in mandatory or considering mandatory PV panels on all new homes, never mind the notional home. Obviously, if they don't do that, then the notional home is not a fixed standard. You don't have to have any PV, but then you have to compensate for that if you go away from the notional house with other measures to achieve the same energy efficiency. So it won't mean you definitely have to have that. I don't think there's any way you're going to avoid, and Simon might tell me I'm wrong, but I don't think there's any way you're going to avoid you'll always need a heat pump in the notional in any house, because you won't hit the notional house standard, otherwise you wouldn't compete, and you wouldn't hit all the metrics for emissions. It'd be impossible.
Yeah.
So
I mean, you can probably get a refurbished house, with some very good thermal wall U values and secondary glazing and a little bit of PV with panel heaters to a B. And I think that's where some people are starting to go with overly insulating and then the panel heaters, because it doesn't cost much. And I have seen some Bs at that level. But, new build houses, in my view, the only way to go should be heat pumps, because they use, 25-30% of the energy of panel heaters. And that's what they cost the same. You've got space to design, have a nice amount of roof space to give you free hot water most of the year round, which obviously drives that cost of the heat pump down even further. Heat pumps have a bad history at the moment because they run at lower temperatures to gas boilers. But with correct design and understanding, that can be completely mitigated. Heat pumps can heat any house in any condition. I just may need more heat pumps in your drafty farmhouse that's 1930s. And, it will cost you more to heat than a brand new farmhouse that's been built to current standards. But, heat pumps will work, and heat pumps are very efficient. The problem is electrical energy is so expensive compared to gas. So whenever you compare it to gas, and the head was in my hands that the government's thought of maybe U-turning on the gas and drilling again in the North Sea oil. And I understand rural communications and it's making the UK more expensive, but then they need to change Ofcam. Ofcam needs to stop costing electrical energy based upon the cost of gas, because it's less and less relevant now. Less and less relevant. 30 years ago it was very relevant, not anymore. So I don't know who's filling their pockets that has wind farms, that has PV, that is being costed 14 pence a kilowatt hour, yet they're selling it at 40 or 28, those sorts of numbers. Don't know who's making that a massive profit. But Ofgem need to change the pricing structure and make electrical. I mean, look in the summer now. In August there'll be no gas. Gas won't be used at all on our grid. So why in August we've been charged 14 pence a kilowatt hour? Because that's the generation cost. So somebody somewhere is absolutely making a fortune. If that's the government, Ofgem, or the providers, I don't know. But we've got to change our structure of having one of the most expensive electrical tariffs in the world.
Yeah, it's an obvious way to promote uptake of electrical heating in existing properties, isn't it? You make it financially beneficial. It's so obvious, it's crying out. And as you say, if the electricity price is artificially fixed, so it isn't particularly beneficial, then not many people are going to do it, because people think with their pockets.
But a good quality heat pump design will be slightly cheaper to run than a gas heating design. And then again, if you can then put PV on doing your hot water, then it will be cheaper. So, you know, will a heat pump pay back in 5 years compared to my gas boiler? No, it won't. No, it won't. The grants will help. You know, you've just got to accept, if you want to heat your house, it's going to cost you more money. And, you know, that's the way life's going to be until the government change the structure of charging electricity. But is heat pumps the right solution? Yes, I'm afraid it is. Should it be mandatory? In my view, yes, it should. And if it costs roguey developers a few £100,000 to make a big block of flats with a central hot water system, then they'll have to sub that up or put the cost on the cost of a flat. But I don't know anybody who'd want to buy a flat today on an EPCD and spend £3,000 a year heating it. And the chances are there'll be a large number of people who bought those types of flats that are going to have a huge problem selling them, and maybe even a huge problem actually affording to live in them.
Okay, well, I see you've got a few more questions popped in. I didn't see them. It's only popped on my screen. So sorry, we're whittling on. And Rachel, did you want to put any more? Have you got time for a few more and try and be more concise?
There's one for Simon. Lee Stewart's request a ballpark figure, please, for a 4-bed detached house, retrofit upgrade with ASHP, PIR controls and AI controlled heating, etc. How much is it going to cost somebody for all that? Roughly.
The devil's always in the detail. We would need to do a model of the house to see whether the radiators, the gas-fired radiators, are large enough. Because the heat pump runs at a lower temperature, there's a risk that they're not. So, you know, best case is you don't need to change any, which case it won't cost anything to change the radiators. Worst case, you know, you could be into, you know, 4,000 or 5,000 to change all the radiators, or any number in between that if there's only a couple of rooms need changing. You know, a heat pump itself with the external unit, you know, assuming it's close to the house, hot water tank, hopefully the space and that with it. But it's probably, you know, 10 to 15. There may be options to make that a bit cheaper. A couple of thousand for some smart controls. 4 or 5 grand for your PV on the roof. Might need a power upgrade. That could be a couple of grand if you have a power upgrade. Is that broad enough? Sorry, there's a bit devil in the detail, isn't there?
Yeah, I think it's as good as you can get, Simon. Good effort.
Last one at the moment. Is there an over-reliance on using lightweight petrochemical-based foam insulation as compared to natural alternatives, e.g. wood fibre? This can also add thermal mass and sequester carbon. Also, care needed with fabric-first approach to retrofitting, insulating historic and traditional buildings. That's a good comment. Yeah. But any?
Well, the obvious thing to say is, of course,
on that foam. We know we don't like foam.
Yeah, I mean, obviously, people get all scared about the fire resistance of foam. Well, all I say is break a bit, take it outside, and try and light it, and you'll see it's not quite the explosive material that some people think it is. But I digress. That wasn't the point of the question. It's twice as insulating in terms of thickness than to fiberglass products, and wood fiber products are even, I think, a little bit less efficient. So that's the reason, isn't it? If you've got so much to put in a cavity without losing floor area, you're going to use the highest possible performance material, which is of course polyisocyanurate foam or urethane foam or one of the equivalents, which will give you a very low K value. Yeah, I totally, excellent point. Yeah, of course you've got to take care, and the expertise is needed for historic and traditional buildings, so you don't damage the historic importance of that building and the fabric of that building. But I think we just need to invent some sort of incredibly high performing insulation that's a bit less plastic based and highly efficient, that can replace it. But until we do, it's going to be Kingsman, Celotex, Recticel, and et al.
Yeah, I mean, there was a number of organic products at Future Build this year. And if anybody's interested in that, I'd recommend a trip to Future Build next year. no connection to me or no reason to sell it. But there's really quite a few nice products where they're using straw-based products, non-flammable and things. So there are definitely more and more products coming on the market that are very organic and very much grown in fields and not plastic-based. I mean, I hear all the time that this is a really lovely historic building. If we're not careful, all those buildings are going to be empty and derelict because nobody can afford to heat them without doing some improvements. I had a grade two listed house, and the way we were going to try and make it carbon neutral was put a field of PV in, and that was rejected by the planners. The lady's got £1,000 energy bill a month, and English Heritage won't let us do this. They won't let us do that. You're on the verge of moving out and just knocking it down, or let it go to rack and ruin because it's just becoming uneconomic for her. So we have to be careful that if you want these buildings to be used, they've got to be habitable. And with modern day standards now, that does mean there may need to be some element of change to them. But if you want to preserve those buildings, then you've got to use them and keep them warm. If they're left to go derelict, then they will deteriorate beyond words, won't they? Or even worse, get broken into and set on fire. So yes, we have to protect our heritage, but we've also got to consider where we're going as a world. Or we'll have loads and loads of derelict grade 1 and grade 2 listed buildings that just fall to bits.
Mm-hmm. Thanks for that. I look forward to seeing some of those new technology systems, but particularly how they can meet the U-value standards. The solutions that we can actually practically use on new buildings. That's the bit that interests me as much as anything. But anyway,
yeah. I mean, Lambswool's been around for quite a long time, and we've put that in. There is a bit of a risk with interstitial condensation with Lambswool, and maybe we just got to suck it up a bit and say, well, occasionally there might be a bit of damp. Does it matter at the end of the world? I'm not talking about some of the awful things you see on houses, but if on certain conditions there's a little bit of damp formed, is that the end of the world? And that often gets dismissed, Lambswool, because there is a risk of interstitial condensation. But maybe we should suck that up and then put Lambswool in.
Well, we could debate that, but we don't have time.
No problem at all.
Okay, that's it for the questions. We'll close it there then. Everybody that's on today will get their CPD certificate sent by email, and we'll also get the recording link out to everybody. Okay, thank you, Simon. Thank you, Trevor.
Thanks for minding the shop, Rach. And look forward to seeing everybody again soon for another stimulating topic.
Okay, so bye to you two, because when I close it, that'll be it, and we'll have to go.
All right.
Chucked out. Okay, bye, Simon. Thanks.
Cheers, Em. See you soon.
Thank you.
Bye now.
Bye.
Cheers, Simon.